doesn't tell you the whole story. But when they demonstrated it, it was real fun, especially uh, when the liver moved and the box was opened and the Coca-Cola was there and somebody said, "Okay, this is yours," and it was a very nice moment. There is a lot of work behind it, by the way. Uh, but again, I'm not asking that you do something similar because of the circumstances. You know what I mean? Let me show you another one. There's something called distance measurement here. We've done some distance measurement. Look at that. You see, I called them excellent. I gave them excellent uh, on this project. Again, there may be some hardware complexities here which we cannot afford doing under the circumstances. Please don't overwork yourself. Don't think that you are required to do hardware. I am not asking you to go out of your way and buy equipment and buy hardware and in a very short time. We only have 2 weeks left to do the project, as a matter of fact. And that's why I would hope that everybody would start on the project as soon as possible, starting this coming Monday. Because after from Monday, Wednesday, well, that's it. You got uh, 2 good weeks to do the project. Remember that you are also responsible for having one or two more lab experiments. One of them for sure is going to be the interrupt experiment. So, but this project was a distance measurement. One of them was a distance measurement. So these are some waveforms and some oscilloscopes and stuff like that. There's not much of assembly language programming. Here is how much hardware on a breadboard. Yeah, you see how much. It's not too much hardware on a breadboard, but it's you know some reasonable codes, maybe 100 lines or 70 lines or 50 lines of code, assembly language programming. Uh, yeah, very interesting. We were measuring distance. So the whole idea was to have a sensor, and we send some ultrasonic, and then it's gonna reflect from the wall. Let's say we need to measure the distance between me and this wall behind me, for example, where you can see King Tut here on the wall. So we would use a sensor, and it will send beam. It will hit into the wall, and it will come back, and it would reflect from the wall, and then we're going to measure the time it took the beam to be reflected from the wall, and we do some calculation. Distance equal to time times speed. Well, the speed, it could be the speed of light or whatever. Yeah, it's probably the speed of light. And It depends on the kind of wave that was transmitted. You need to really look for some charts and stuff on the data sheets of the sensor. And then once you have reflection, that's gonna cause an interrupt. And the interrupt will actually, the interrupt service routine is gonna measure the time difference between the signal sent and the signal reflected. So it's fun to measure the distance. Again, I don't insist on having too much hardware. There is a real fun project here that I would like you to. It's called collision avoidance. Let me use another explorer, maybe. Let me go to another. You haven't seen anything moving yet, right? Yeah, here you go. I'm gonna click that. You wanna see it again?
Yes.
Okay. It's
Stop scrolling. I found the best way to beautify and brighten my home without batteries or messy wires. I like to keep a beautiful home inside and out. Recently, I've been meaning to.
we called it a collision avoidance robot. It's not a robot. This is not a robotics course, but it's an attempt to use the trainer to create motion and things like that.
Professor, I believe you need to go to the previous page. I think this is a separate video.
I know.
Mhm.
They have some more than one application on this uh, thing. Uh, just a second. Yeah, we're gonna reproduce that. You see it now?
Yes, it's showing right now.
I'm sorry?
Yeah, we can see the video.
So
Professor,
did everybody see the robot moving?
yeah, is there a way to make the robot or the car move by voice command?
Move by what? I'm sorry.
Voice command.
Why not?
You can. Oh, that's cool.
Yeah, yeah, but the problem is, do you have the time to do it? Do you have the tools to do it?
Maybe. No.
Let me tell you something. Um, you know the in my 447 class, my students purchased an oscilloscope, a signal generator, power supplies, multimeters, and I was surprised to know that they purchased this stuff. You know, the some cheap Chinese equipment. You know, the Chinese are they have very cheap stuff in the market. You can buy an old machine, an old equipment for maybe $50, sometimes for a couple of $100.
Professor. Like there's
Yes,
also like, I mean, like there's also DigiKey. That's where I buy my like
I'm
my
sorry.
so like DigiKey. It's like a website. Uh, you can buy stuff there. It's really cheap as well. They have all sorts of brands. Like I bought a beginner soldering tool there, so I mean it's a good resource. And they have like other stuff as well, like power supplies.
Yeah, 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 yeah. That's what I'm referring to. Yeah, maybe we can chat about that later. You can give me that website later. But again, I'm not saying that you will do this in 2 weeks, because you're not gonna start doing this today. Today you would be doing the 7 segment display. In the weekend, you probably are gonna catch up with some homeworks and some labs. The real beginning, I would say, you're gonna start probably Sunday or Monday doing thinking about the project. So I want to
And I
have
have a
some
question.
groups.
I have a question. What chapter do we look into if we wanted to use the breadboard on
What
the Jetpack
chapter?
Pro? Yeah, what chapter do we look at for like input,
There is
output?
no chapter. There is no chapter. As a matter of fact, this is based on your lab experience and the things that you learned about interfacing
Oh,
in this course. But your question is good because there are some chapters that you can read on your own. There is a chapter 13 and chapter 17 in the book. I think chapter 13 is talking about A to D converters,
okay.
and chapter 17 is talking about a motor.
P. Yeah. Okay.
There is a built-in A to D converter.
Oh, that's great.
There is a built-in A to D converter. Bill, your name is Bill, right?
Will.
Will, yeah.
Or what? Yeah.
Will or Bill. Some people call
Yeah.
Will, some people call Bill.
Yeah. Okay.
And you can have some people use chapter 13 to understand more about the internal A to D converter that comes with the processor.
Okay.
Some people use chapter 17 to learn about the motor, because the motor you have to control the speed, you have to do some configuration, you have to control the direction of rotation.
Okay.
All this control is accomplished by good selection of bits in the output ports and the input port. The A to D converter, of course, is connected to an input port. The
Okay.
motor is connected to an output port, and we can have all the time in the world to do these things, but uh, we not only have a shortage of time, but we also have